Good day, students. You're welcome to mathematics class. Today, I want to talk on the topic says joint variation. As you all know, that we have four major types of variation. We have what we call direct variation. As you all know, what we call inverse variation, joint variation, and partial variation. Before we can be talking about these joints, we must have known knowledge about direct and inverse. So the two combining together will give us joint. And after we must have talked about joint, that's why we'll now be talking about partial variation. But today, we want to talk about joint variation. In that joint variation, you can have two directs coming together or direct and inverse coming together. Let's take these examples. The first example says, if y varies directly to av squared, y equals 15, a equals 2, and v equals 3. The questions we have here is that we are asked to find the constant of the proportionality. Second question here, we are asked to find the relationship between the variables. Another question here, we asked to find the value of y when a equals 5 and v equals 6. So, and the last question here, we have to find the value of v when y equals 90, a equals 12. So let's look at these questions. The first thing we are going to do is that this question, we have y varies directly to a and v square. We want to look at this. Like what I said last time, joint variation. We have two direct variation here. Y varies to a as well as y varies to v squared. Combine these two together, y varies to a, y varies to v squared. By the time we combine the two together, that's what is giving us this. On that note, we now have y equals to kav squared, as you know that k equals constant. If k equals constant, we are given some values. Y equals 15, a equals 2, v equals 3. Let's substitute this value to this equation. That means 15 to be equals to k times 2, which is a, times v squared, which is 3 squared. This will give us 15 to be equals to k times 2 times 9. So this 2 will give us 18. We're having 15 equals to 18k. We divide both by coefficient of k, which is 18. Divide by 18. This one will go. What divide this? That should be 3. 3 here will give us 5. 3 here will give us 6. Therefore, k equals to 5 over 6. According to this question, the first question is that we should find the constant of the proportionality. This is the constant of the proportionality. This is the constant of the proportionality. Let's take the second question. As time goes on, we'll be making reference to this constant of the proportionality. Question B, let's do the two together here. B says we should find the relationship. How do we get the relationship between the variables? The variables are y, a, and v squared, including this. We'll now substitute this k to this equation here. That is, whenever we see k, we put 5 over 6. Therefore, y equals to 5 over 6 av squared. This is what we call relationship between the variables. This is what we mean by relationship between the variables. So let's go ahead by trying to solve the remaining questions. The remaining questions, we are asked to find the value of y when a equals to 5. We have to find y when a equals 5. When a equals to 5. That is, question C, we are asked to find the value of y when a equals 5, v equals 6. Let's go back to our relationship, which says y equals 5 over 6 av squared. Now, our a now is 5. That is, y equals 5 over 6 multiplied by, what is a? 5 multiplied by 6 squared. 6 squared. We have it as y equals to 5 over 6 times 5 times 6 squared will give us 36. Let's make it over 1 over 1. 6 here 1. 6 here will give us 6. 5 times 5 will give us 25. Or better still, let's do it in this way. 5 times 6 will give us 30. 30 times 5 will give us 150. Therefore, y equals to 150. That is the value of y when a equals to 5 and when v equals to 6. And the last question there, the last question, that is the value of what do you say, v, the value of v, that's what I want to get now. V, that's question D, the value of v when y equals to 90 and a equals 12. That's what we have there. And how do we get this one? Go back to relationship, which says y equals 5 over 6 av squared. That's what we have there. Now y is 90 now. I'm having 90 to be equal to 5 over 6 multiplied by a is 12. 12 over 1 times v squared. We agree here that this here will give us 1, this here will give us 2. We're now having 90 to be equals to 10v squared. We divide both sides by coefficient of v squared, which is 10. This one is 10. This one will go. This one will give us 9. That is, v squared equals to 9. And how do we remove this one? As we all know, on this note, we find the square root. That is, square root both sides. Why are we square root? We need to square root both sides. When you want to eliminate square, you square root. But when you want to eliminate square root, you square both sides. Since we want to eliminate the square here, definitely we are going to square root. And square root means that v square into the square root equals to 9 into the square root. This one will go. Therefore, v equals to, people say plus or minus 9, but on this place, let's stick to our 9, that v equals to 3. When we find the square root of 3 of 9, we give us that v equals 3. That is the first question there. Let's take another question which will serve as our example number 2. The question says, is a long statement. Z varies directly as y and inversely as the square root of x, and z equals to 5 when y equals 3, x equals to 9. So the first question there says that we should find the relationship. The second question says that we should find the value of z when y equals 18 and x equals 25. The third question says we should find y when z equals 12.5, x equals 81. And the last question says we should find x when z equals 20, y equals 4. Now, let's do them one after the other. The other example, we said the two were, the variables there were direct, but this time around we're having direct and inverse. So we have it as this, that is, z varies directly to y, and it also varies as the square root of x. Square root, that is, also varies directly to the square root of x. When we now combine these two together, it gives us inversely, yes, z inversely of this. Z will now be very inversely to y into 1 over square root of x. This is a combination. At this point, it means, therefore, z equals ky into square root of x. We all know this one, that's y times 1 times k. By the time we change it to equal sign to the square root of x. But we are given some values, that is, z equals to 5, y equals 3, and x equals to 9. Let's substitute this value to this place. We have 5 to be equals to our y. That's 3k over square root of 9. This one will give us 5 to be equal to 3k over square root of 9 will give us 3. From this point, we can let this one go by cancel this, or we cross multiply. We still arrive at the same answer. This one will go because this is over 1. Therefore, k equals to 5. If k equals to 5, then they ask us to find the relationship. Relation will be, we are now taking this one back to this place. Therefore, the z will now be equal to 5y into the square root of x. That is the relationship there. That is the relationship that we have there. So if you have that one as relationship, so let's write it in this way. This is relationship. Some people call it equations. Some call it expression, or a formula that connects them. That is about that one. We are through with A. B now said that we should find the value of z. Z when y equals 18, x equals 25. We should not forget our relationship will be our base, the formula we are going to solve as many questions we want to solve there. Z to be equal to 5y into square root of x. Don't forget this is our relationship. We now have z to be equal to 5 times y, which is 18, all over square root of 25. Z equals to 5 times 18 over 5. The square root of 25 will give us 5. This one can also go. Therefore, z equals to 18. That's all about that one. And question C said that we should look for y when z equals 12.5 and x equals to 81. Let's go back to our relationship. That is z to be equal to 5y into square root of x. This one will now give us 12.5 to be equal to 5 multiplied by y that we are looking for. That's 5y into square root of x. Our x is 81 into 81. This one will now give us 12.5 to be equal to 5y. The square root of 81 will give us 9. There's something we are going to do that we call cross multiplication. We are going to multiply this, and when we cross multiply this one will now give us 5y to be equal to 12.5 multiplied by 9. I normally tell my student, let's multiply this one somewhere. 12.5 multiplied by 9. 9 times 5 will give us 45. We are going to keep 4. 9 times 2, 18 plus 4 will give us 22. 2. We are keeping 2 this time around. 9 times 1 plus 2. That's 11. We have this. That is 5y to be equal to 112.5. At this point, we divide by coefficient of 5. This one divided by 5. This one divided by 5. When you divide it to the lowest term, then this one, that is this 5. 5 here will give us 1. Let me write it very well. 5 here will give us 1. 5 in 11 will give us 2. Remainder 1. 5 in 12 will give us 2. Remainder 1. That 1, remainder 2 rather. That 2, since cannot go, and the decimal point here, we have it here. Now, that 2 and 5 give more 25. 5 and 25 will give us 5. So the value of y When we have this value, we give us 22.5 there. And the last question, that's we should look for x. That is question D. X when z equals to 20, y equals to 4. We should not forget our relationship which says z equals to 5y into square root of x. At this point, we have 20, which is our z, to be equal to 5 and y times 4, f it over square root of x. This is over 1. Let's cross multiply. 20 times square root of x will give us 20 root x to be equal to 20. We divide both sides by coefficient of root x, which is 20. This is 20. This one will go. 20 and 20 will give us, 20 divided by 20 will give us 1. That we have root x to be equal to 1. We now square both sides. For us to remove the square root sign, we square both sides. That is, square root of x square to give us 1 raised to power 2. This one will go. We are now left with x equals to 1 raised to power 2 will give us 1. So the answer here is 1. So I want us to take note, the answer here is 1. So let me just give us work to do for the next, before the next class. That will serve as our assignment. Let's have this. P varies directly as the square of Q and inversely as the square root of R. P equals 48 when Q equals 4, R equals 25. The question now says we should find the relationship between the variables. The second question, we should find the value of Q when R equals 36 and P equals 24. And the last question says we should find the value of R when P equals 10 and Q equals 6.4. Question number 2 says, if W varies directly as the square of V and varies inversely as L, small letter L, find the question A, value of the constant. B, say we should find the relationship. Question C, we should find the value of V when W equals to 800 and let's say and L equals to 40. And the last question, we should find the value of L when W equals to 1600 and V equals to 250. These are the two questions I want us to work on before the next class. On this note, I want to call it a day. Thank you, students. Have a nice day.